Hi all. Let's start with the next video. PCIe transaction layer. I already told you like PCIe having a layer protocols. Till now what we discussed up to enumeration we completed. Now we are going to start the actual layers of PCIe. So in these layers we are in PCIe we are already explained. We have majorly in three layers for hardware point of view. First one will be the transaction layer, next will be the data link layer, and third will be the file layer. So I will revise once what we discussed till now. Initially, I started with protocols, basic protocols and some definitions, types of protocol, and then after I started with OSI model, Open System Interface. Using that layer-wise protocol, we have a 7 layers. So in that we are dividing from hardware and software point of view. Then after I took as a one example for PCIe how data transfer will happen from your system memory to any endpoint. Let's take as if you connect any hard disk in your system, how you can able to send data from your system memory to any hard disk. So I took as a one simple example for that. Then after I went through enumeration, the process of detecting any device we have to do as enumeration by using that device function models. We did some sending packets through EP, RC to EP, so to get the behavior of the endpoint, how what is the memory space is and what are the fields is present, everything we discussed. Now we are seeing next is a transaction layer. Uh, in transaction layer, let's show the layers guys. In PCI we have a three layers majorly. One will be the transaction layer, data link layer, file layer. So before going to transaction layer, just I will walk through some basic understanding before going to transaction layer. Every device we have a first step will be the reset. Reset is a state. We need to start from the reset only, because if you are using any initialization, so anything you want to reset, so reset is the first step. Once a reset is done, you have a RC, you have a EP, you have to do the link training. This we call as a link training state mission will be there, LTSSM. So we'll see in a file layer how link training will happen. As we go forward, you will understand in a file layer how link will happen. As of now, understand this will be the RC. This is a host. This is the EP endpoint is connected through this link training. This link will be connected. Assume as a link is connected default. So once reset is done, it will start as a link training. Link training will start. Link training will start. Once link training in a LTS system, we have a state where we can able to send the actual data actually. If you are sending any configuration packet, anything you want to write the data, any hard disk, if you see this is a CPU, this is a hard disk. So anything you want to write the data from your CPU to any hard disk, it should be done with a link training. Once link training is done, in a link training we have a state where we can able to send the actual data. Whatever data lists I want to write the data 10101010. This is the data you want to write for any hard disk, any address. So this is one example. So you want to write that actual data. So what happened once in a link training we have a L0 is a state will be there. Once FSM reaching to L0 state, so what happened? We will tell to link is activated. Means link is connected to RC to EP. So L0 is a state, only a state we can able to send the actual data that we call as a link up. So physical layer will tell to data link layer, how link is up. So once LTSSM FSM reach to L0, file layer will tell to data link layer, link is up. Once link is up, so data link layer will do as a initialization process will do. So we will use as a some buffers where we call as a virtual channels. So initialization will do data link layer. How initialization will happen, we'll see in a data link layer. So my point here is was the actual process is going from pi to transaction layer. So instead of going directly transaction layer, we'll see what actually happened behind. First physical layer will do some operations. Link up is will happen. Once link up will happen, the file layer will tell to data link layer, link is up, so you can able to do initialization. Initialization is done for data link layer. Once initialization is done, then only you can send the actual data from transaction layers. So actual data means packets. You can able we can able to write it to send the packets. So once initialization is done, then only data link layer accept those packets. So transaction layer will create automatically packet, but it won't be sent. Once installation done, then only it will start sending the packets. So once virtual channel is 0 is done, installation is done, automatically it will start as a configuration packets. Configuration packets. So configuration read and writes will happen beginning. So this is the way file will tell to data link layer to transaction layer. This is the flow we need to understand here. This is I want to convey before going to start the transaction layer. Now we'll go with a let us assume link is up, link is connected to EP, any hard disk. So you are ready to send the actual data. So in actual data means your the processor will giving us the instructions. You want to write the data to any endpoint, any hard disk. So transaction layer, what it will do, it will generate as a TLPs. So each TLP will in transaction layer we have a different types of TLP that we need to discuss here. Moreover, in transaction layer, we have a one transmitter block and receiver block. Both can happen. It may be send, it may be receive packets. Both can happen concurrently. So from transmitter side, we have to create the packets appropriately. The processor will give instructions based on instructions that the data. The whether you are creating configuration packets or memory read packets, memory write packets, based on that processor requirements. Processor will initiate to bus PCI interface. Based on that requirements, transaction layer will generate the packets, different types of packets. This is the transmitter end, it will send the packets. From receiver end also, it's can able to receive the packets from the EP to RC side. So both can happen concurrently. So from transmitter end, what are the challenges we need to face now? Create a different type of TLPs and send to DL layer. This primary responsible what happen, create the packets, and completions also you will get from the receiver to transmit, from EP to RC. So both transmitter, receiver both can happen. So these are the challenges we need to see the, these are the packets we need to see from the transaction layer point of view. From receiver's end also, in DL will send to TL layer to check the correctness, or we you need to see the what are the packets we are getting from the DL to TL layer. Once reaching TL layer, it will check the CRC. Once the CRC here also, it will check the CRC. CRC checks is done, then only it will send that data to that core. So the both can it will happen in a concurrent way. So from transmitter side, we have a receiver side, we have a two interfaces. This interface we call as a custom interface. So internally we will use to communicate the two layers. So this is I want to convey. Here is a moreover in transaction layer I told you we are generating a packets. So what are the types of packet we are going to generate? Moreover, here is the four types of packet we are going to generate. One will be the memory read and write. Second will be the IO read and write, configurations, and message TLPs. So as we go forward, you will understand what are the packets, what are the fields is present in each packet, and what are their significance, how to implement in the features, any features will be there. So in order to improve the performance point of view or any specific related, we'll see in a next slide. Till now, let's quick overview, like what is the PCA, how PCA initially initiating to core to any PCA controller. Then after reset, link up. Once link up is done, data link layer will do initialization. Once initialization is done from the data link layer, it will automatically send to packets, actual packets to TL to DL to file layer. File layer will frame the packets to appropriate way. Then it will send through that link. This is the link. It will send the packets to from transmitter to EP side. So in this way, packet formation and packets will send from transmitter to receiver or any RC to EP side. So I'm going to cover in this video up to this. For next video, we will see the what are the types of packets and what are the different types of formats and types, and each field the significant. We'll see in a next video. Thank you.